of what we did on Friday, the 7th of November. We started identifying and representing functions, where your essential question is, how can you identify and represent functions? You had a paper of notes that I had printed off for you that we took notes on. If you will tape that to the back side of the previous page, what I'm going to do now is go back through the pages of the assignment of the lesson with you, and I have my printed copy here. We talked about this being a function machine, where we would put in the value of x, the machine would work on it, and we would get the value out. We have a sample problem here that it took us through several steps that we had to do, one of which was we took the information from the problem and we filled in the cost from the problem, and then we described any patterns that we saw. And one of the things that was mentioned in class was that each pencil cost 25 cents, and what we were doing is we were taking the number of pencils and multiplying it by a quarter, by 0.25. And so if we then followed what comes on the next page, we would then extend that to any number of pencils would be multiplied by that quarter. So we would have 0.25x. And Carlos wants to buy 12 pencils, so what would he have to pay? Well, we're going to do the process, which this is the rule, and we would find out that he would need to pay $3. And as I said, some of this continued at the top of the next page. I didn't assign these, and that's fine. If you want, you can go through that and see what you can do. We went from there to identifying functions from mapping diagrams. Here's some of that vocabulary that's on that notes page that I gave you. This is a mapping, and what you're looking for is that each input only has one arrow, and as long as each input only has one arrow that connects it to an output, then you have a function, because a function is 1 to 1, and we said the x does not repeat. Okay, and there's more to this example on the next page, and this is what I was talking about. An input can have one arrow, that's great, but if you have two arrows that connect that to outputs, then this is not a function. This might be a good one for you to think about, but I'm not assigning it. At the end of class on Friday, we had said if there was time in class, then you were supposed to do some problems. You are required to complete 4 of the your turn here. This goes back to example 1. Example 2 takes us into identifying functions from tables. And again, you're only wanting to look at the output. 5, 10, 15, 20, 25, no repeats, so this one is a function. And that is the entire theme of this lesson. You only care about the inputs. The outputs are there, and that's fine. They can repeat. It's okay if the outputs repeat. What we don't want is for an input to repeat. As long as there are no repeats here for the inputs, you have a function, and that's what we're working on. The second part of this example gives us 1, 5, 4, 1. We have a repeat right there, not a function. Very simple. And yes, I assigned these your turn problems, and you do need to do those. The third example takes us to graphs. And this is really rather simple. all you need is a vertical line, and what you're looking for is that only 1 point. And at this point, we have 2 points that have the same x value, which means the x is repeating. This is not a function. And we have this set right here. We also have another set right there that if we take our vertical line and we go from left to right across our graph, anytime it starts touching more than 1 point, it's not a function automatically. If we only had the single points that it touched, that would be great. It would be a function. But because we have not just one, but 2 sets of multiple points on the vertical line, it's not a function. Yes, I assigned your turn here. When you come to class on Monday, you will have those problems to do, plus you will be assigned 1, 2, 3, 4, 5, and 6 of the guided practice. Let me show you 6 there. All of these problems here need to be completed, and I want you to do number 7, and then you're going to be assigned all of the problems. 8, 9, 10, 11, 12, 13, 14, 15, and 16. And those will be taken up at the end of the period. So that is the review for 6.1.